there. Today we are going to talk about the properties of addition, and so I'm creating this little video for you to go over some of the vocabulary and then to give you some examples of the properties of addition. The really cool thing about the properties of addition is the properties of addition and the properties of multiplication are very similar, so you will see some of these same properties again when we talk about multiplication. So let's talk about the vocabulary. Your first word is equation. An equation is just a number sentence with an equal sign. An example of this is 4 plus 10 equals 14. This is an equation. A group is how things are put together, and they're usually in parentheses in math. Properties are characteristics that make a thing what it is. So this is like the properties of you. You're a 5th grader. You're taking a math class. If we identified your hair color and your eye color, these are characteristics of you. Just like with math, the properties are characteristics of whatever we're working on that make that thing what it is. Now, a number sentence, much like an equation, is going to have numbers, but instead of an equal sign, you're going to have a greater than, less than, equal to, or greater than or equal to, less than or equal to sign. So for instance, 2 plus 4 is greater than 1 plus 2. 2 plus 6 is greater than or equal to 4 plus a variable, the letter A. Okay, that means that whatever is put in A has to make this number sentence true, that this side would be greater than this side. We will not deal with this right away, but you will see it as we get into some of the deeper math problems and things like that. So again, mainly you're going to be dealing with greater than, less than, or equal to at the beginning of the year, and then we'll deal with these later on in the year. So you might be thinking to yourself, what are the properties of addition? Well, the 3 main ones that we're going to deal with today are the commutative property of addition, the associative property of addition, and the identity property of addition. So let's talk about commutative. Commutative property. Now, there is a commutative property from multiplication, but we're going to look specifically at addition. Basically, it says that we can move the numbers around, move the addends specifically around, and our sum is the same. It doesn't matter how many addends you have. You can put them in any order, and your sum is still going to be the same. So that's like saying, okay, we have 7 plus 3 equals 10. Well, we can turn that around and do 3 plus 7 equals 10. It doesn't matter what order the 7 and the 3 are in, the sum is still going to be 10. Again, if we want to deal with larger quantities of addends, we could say 4 plus 5 plus 6 plus 9 equals, well, that's 10, 19, 24. We could say 4 plus 6 plus 5 plus 9 still equals 24. 4 plus 9 plus 6 plus 5 equals, you guessed it, 24. Now I can put a different number in the front. I can say 9 plus 5 plus 6 plus 4 still equals 24. The possibilities are endless until we run out of and start repeating the order of the addends. The community property says we can move the addends around, but the sum stays the same. I think of this like transportation, commute. We can transport the numbers. Here's my little feeble attempt at being an artist. Here's my car with a car door and a window over here. I don't know. I'm not a very good artist. Here's a muffler. Boop, 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 boop. Boop, 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 boop. All right. We can move it around, transport or move around. All right. I did not ever say that I was an artist, just so you know. Never ever did I say that, and I would never claim that. All right. Next is the associative property of addition. The associative property of addition. This is the same also in multiplication. You can put the addends with whichever addend they want, and it stays the same. So you can group the addends in different ways. And the sum stays the same. All right, so an example of this would be 3 plus 4 plus 6 equals 13. Well, right here, the 3 and 4 are hanging out, but guess what? Let's say the 3 no longer wants to be friends with the 4, and the 4 and the 6 want to hang out. Well, 6 plus 4 is 10 plus 3 equals 13. So it doesn't matter who they're hanging out with, the sum is going to stay the same. And you can do that with several numbers. You can do it with 3 numbers. Let's see, if I did something like this. Let's go with 2 plus 8 plus 6 plus 5 equals 21. I could change that around and I could say 2 plus 6 plus 8 plus 5 equals 21. I can change my parentheses. I could move them around within the parentheses. Any of that is fair game. It does not change the sum. The sum stays the same no matter who the numbers decide to hang out with or how they're grouped. And remember, with grouping, we're going to use these fancy parentheses. All right. If you're with me so far, then we will move on to the final property that we're going to discuss today. Now, again, this is a property that occurs in multiplication. It just looks a little different, just like the other ones. So, this is the identity property of addition. The identity property. Basically, it says we can add 0 to any addend, and that addend holds its identity. So anything plus 0 is itself. Okay? Anything plus 0 is itself. You can add 0 to any number and it doesn't make a difference. The sum is still the number. For instance, 5 plus 0 We're not adding anything to the 5, so the 5 keeps its identity. 1,275,248 plus 0 is still going to equal 1,275,248. It doesn't change. It holds its identity. Anything plus 0 is itself. Excuse me, I had to sneeze there for a second. All right, so now we have defined the different identities. The next video will be some ways that we can play around with the identities. We'll work some numbers. So this has been a long enough video for you guys. And, if you have any questions, come by and see me.